So in this video, we will talk about slopes and the derivative, differentiation rules, and higher order derivatives. So let's start with the following. Madali lang naman maalala kung ano ibig sabihin or ma-imagine kung ano ang ibig sabihin ng tangent line to a circle at point P. So it is characterized by the unique line that intersects the circle at exactly one point, which is P. Madali lang ma-recognize yan. But our concern is how do we define the tangent line to a general curve? So to answer this, let's consider the following curve and 2 points on the curve, P and Q. So take note of the coordinates. So when we connect those 2 points, that is what we call a secant line. Our next question is, how do you compute for the slope of this secant line? So recall that the slope is computed from the differences of the y's over the differences of the x. So we have this formula. And then let's do a change of variable. So let's say we let delta x to be the change in x so that yung slope sa taas can be written in this manner. So x0 na lang, tapos mawawala sa picture sa x1, it's replaced by delta x. So let's try to move Q closer to P. So when we do that, yung x1 approaches x0, yung x coordinate sa lapit, and so the difference delta x tends closer to 0. So pinapalapit natin ang pinapalapit hanggang yung mga secant line natin approaches this line L. So ang tanong natin, what is the slope of the line L? So we know the slopes of the secant line, tapos pinapalapit natin yung mga secant line kay line L. So to get the slope of line L, you just get the limit of the slopes of the secant line. So you let x1 approach x0. So we also recall na nagkaroon tayo ng change of variable. So delta x is x1 minus x sub 0. So the slope can also be written as the limit of this expression. So ngayon yung line L na yan, that is what we will call the tangent line to the graph of y equal to f of x at P. So here is a formal definition. Given a function defined on an open interval containing x equal to x0, yung tangent line to the graph of f at point P is defined as, so number 1, it is the line passing through P whose slope is given by this formula. So again, kasi kapag may line tayo, pwedeng para makuha natin yung equation ng line, may slope at saka point. So dito alam natin na yung slope ay itong formula na to, tapos yung point si point P. We can also have that the tangent line is the line with the equation x equal to x0. If you evaluate the limit of this expression, as delta x approaches 0 from the left at saka right, dapat parehas pupunta yun ng positive or negative infinity. Kung di ito mangyayari yung si 1 and 2, wala tayong tangent line sa graph of f at P. So some remarks or properties of your tangent line. Yung tangent line natin, it gives us an idea of how flat or steep the graph of f at point P. So, ganun din naman for line, di ba? Kung positive, from left to right, dapat parang pataas siya. Kung negative, pababa naman. So, medyo ganun din yung idea para dito. And unlike dun sa diniscuss nating tangent line to a circle, the tangent line to a graph can intersect the graph pwedeng once, pwedeng twice, and so on. Pero definitely once kasi dadaan siya kay P. Pwedeng lumagpas pa. And then, meron tayong tinatawag na normal line. So, the line normal to the graph of f at point P, siya daw yung line. So, dumadaan na siya dun sa point, pero yung line na yun ay perpendicular dun sa tangent line. So, sana nare-recall natin kapag may dalawang perpendicular lines, ano ang masasabi natin sa slope nila. So sa illustration na to, the red line is the tangent line at point P. Yung blue line is the normal line. So as an exercise, let's give the equations of the tangent and normal lines to the graph of f of x equal to 1 over x at x equal to 1. So again, to answer these types of questions, or yung equation ng line, so you need the point and the slope. No? So you need to recall your point slope form. Y minus y naught equal to m times x minus x naught. Here, yung point na kino-consider yung x naught, y naught, C1, 1. Kasi alam natin, kino-compute natin at x equal to 1. So to get the y coordinate, you just plug in x equal to 1 dun sa f of x. So ang concern natin, what is m? So yung m dito is the slope of the tangent line. So kaya natin diniscuss yung limit kanina kasi that is the formula that we will use. So again, the slope of the tangent line is given by this limit as delta x approaches 0. So, yung 1 plus delta x, you just plug it in f. So this is the expression. Let's try to simplify, evaluate this limit. Simplify or put this in a simple fraction. So you multiply the numerator and the denominator by 1 plus delta x. And then simplifying the numerator, you get the expression to the right side. And then, this is an indeterminate form, 0 over 0. Madali lang makita that you need to cancel delta x. And as delta x approaches 0, this expression is equal to negative 1. So here, the slope of the tangent line of f of x at 1, 1 is negative 1. So we have that the equation of the tangent line is y minus 1 equal to negative of the quantity x minus 1. So again, ano nga ulit yung relationship ng slopes ng perpendicular lines? So ang tawag natin negative reciprocal. No? So dito, since the slope of the tangent line is negative 1, so yung slope ng normal line should be negative 1 over yung slope ng tangent line, which is negative 1 din. So ang slope ng normal line is equal to 1. So the equation of the normal line should be y minus 1 equal to x minus 1. Tapos dito, pwede rin ulit tanongin, what if you want to compute for the slope of the tangent line at x equal to 2, x equal to 3, and so on. Pag ginawa nyo yung mga exercises na yon, you will see a pattern. In general, we can compute for the slope of the tangent line for any value x. So, i-fix mo lang kunwari dito sa x, hindi siya parang variable. So, the slope of the tangent line at x is this limit. So, using the definition, linag-in lang natin siya dito. And then, let's simplify this fraction. So, you multiplied, what did you multiply? X times the quantity x plus delta x. Yun lang yung nangyari. Simplifying, we get this. And then, kung maalala nyo kanina, indeterminate form yung mangyayari din dito. You need to cancel out the common terms. And then, so para mag-cancel ang delta x, you are left with negative 1 over x times the quantity x plus delta x. And as delta x approaches 0, ang matitira sa'yo ay negative 1 over x squared. Again, tinitreat natin constant dito yung x na yan. Naka-fix siya. So at x equal to 1, yung slope of the tangent line, you just need to use this formula. So negative 1 over 1 squared. So that is equal to negative 1. Na-verify na natin yung kanina. At x equal to 2, no need na ulit-ulitin mo tong mga ginawa natin dyan. Isalpak mo na lang yung x equal to 2 sa negative 1 over x squared to get that the slope of the tangent line of f at x equal to 2 is negative 1/4. So in the previous example, nakapagbigay tayo ng function yung negative 1 over x squared that gives us the slope of the tangent line at any value x. This function is what we will call the derivative of f.